Hi, I'm Paul Burton, and welcome to the first episode in our series, The Science Lesson Support System. Our system and framework methodology will enable the student to rebuild the information that you gave them, and not by memory alone, but by intuition. It will also help the teacher build a more confident and enjoyable science plan. The system is suitable for primary and post primary from ages 6 right through to adults. We highly recommend hanging around through our methodology chapter as it's just as important. But if you like, you can skip to the Science Lesson Support System chapter using timestamps below. So let's get started. A major drawback in science in general is it depends heavily on memory retention, and it's easy to fall behind if we don't grasp a concept early. We want to balance out that academic memory advantage by offering a way for all students or all adults alike to have the toolbox to rebuild and recall their science learning intuitively, even years later. It all starts with needing a platform to build the learning information from. For example, if you want to learn a language or learn to write, you have an alphabet to work from. If you want to learn maths, you have a numerical sequence to work from. History has a historical timeline organized by date, and geography, in its basic sense, has a world map to point to. So, what does education and science have for students to connect all of the dots? Well, currently, science as a curriculum exists in free floating block topics. The topics themselves are great, but it simply lacks connectivity and integration. This connectivity and integration is vital to help the student recall information when needed. But I'm happy to tell you there is a scaffolding to help you and your students to connect topics and enable the student to learn and recall information intuitively. This will also provide a superior predictive toolbox for the student. We need to hunt down a super common denominator, one that has motive, fits the description, one that's been found at all of the scenes. All topics must lead back to them. STEM education as a primary subject is essentially the study of what atoms, molecules, and light does, and how that impacts living things. And whoa, where are you all going? Okay, it's the word atoms and molecules, isn't it? You see, us adults have a tendency to think atoms and molecules are only relevant to complex, higher level learning. But I'm here to prove to you that's not the case. These resources and the method we will cover is suitable for ages 6 plus all the way up to adults and long life learners. Atoms and molecules are just words, no scarier than banana or apple or hippopotamus. If children can say the word hippopotamus and know what they're talking about, then surely they can say the word hydrogen and know that something is a hydrogen. I'm here to dispel this fear and reassure you that what I'm about to show you is as easy as understanding and as using Lego, and it's just as much fun. Welcome to the Science Lesson Support System, your compass to help guide you through STEM for ages 6 and all the way to adults. When we teach science, we're telling a story, the true story of nature. Atoms hold hands to make molecules, and molecules group up everything we can see, smell, touch, eat, or drink, including humans, all plants, and all life. It's actually that simple. Knowing the most basic rules of nature is the difference of learning about climate change and understanding climate change. And all forms of light and forces all interact with those molecules, informing everything we do every day. And it all comes back to the atom, your one stop shop. Resource displays like this, along with individual packs for each student like these, will help add depth and direction to your existing lesson plan. The best thing about this approach is that the resource themselves remind you through a look, read, and understand method that tell you what is going on at one glance. So you won't need to pull out the revision books every year. We explore this during our resource section later on. Atoms and molecules are the one single thing that can be linked to absolutely every STEM topic you will ever teach because they make up everything. It's given rise to this funny meme. Let me show you how easy they are to use. Real atoms are like mini magnets. They love making friends. They have different amount of connection holes, just like our hands, so they can hold more friends. When two atoms or more are connected together, you get a molecule, just like a group of friends holding hands. Stick and ball chemistry sets are fun to use and help improve fine motor skills. In fact, the very act of connecting these little atoms together is also quite relaxing and will inevitably unlock the creative talents of students for shapes and basic geometry, which is important in material science, pharma, and the food industry. A fun fact, but no matter what molecule the children build with a handful of these little atoms, chances are nature has made that very combination at some stage in the history of the universe. We love to encourage the students to name an original molecule that they build by taking their last name and putting onium after it. For example, my molecule would be called Britanonium. A bit of a mouthful, but my patent hasn't made me rich yet. But in the real world, that's what they have patents on. So let's look at the powerful and far reaching impacts that these wonderful resources can offer, all for around 15 to 25 euros per box on the internet. We encourage you to shop around. They all seem the same quality in our experience. I'll tell you the basic things you need to know, but I'll also drop in some slightly higher optional info for those that might like to know. I'll let you know when I do. So let's take a look at how these resources can explain real atoms, real nature, and reality. Atoms are the building blocks of all stuff. When two or more atoms make friends, they form a molecule. Each color represents a different type of atom, also known as an element. Each hole represents a real spare electron bond. Everything you can touch, smell, see, or feel are all made of molecules. And even the angles of the connectors represent real atomic bond angles. Inside the box, you will find that all these little things represent atoms, the smallest unit of mass that make up all stuff. Each color represents a different element. There are usually only about 5 to 8 types of element in a box, but you'll only ever need to associate yourself with 5 of them. They are the black one, which is the element carbon, the white one, which is the element hydrogen, the element oxygen is red, nitrogen is blue, and silver can be any metal you want it to be. These 5 types of atoms are really all you need to know about. For primary, you don't need to be concerned about why each color has different amount of holes. But to keep it easy, you can just simply call all reds oxygen, all blacks carbon, all whites hydrogen, and so on. It's important to keep things simple and have fun. Young students don't have that fear of chemistry that we once had. You will find that they will pick it up very quickly, so don't be afraid to challenge them. In our experience, they're well able for it. It's also really important and really interesting to know that real atoms never just disappear in a real reaction or a violent explosion like fire. Nature always recycles all its atoms. So every single atom gets repurposed every time. It's green recycling credentials right there for you. The small sticks we called hands earlier are electrons, which are part of an atom and explain a lot about nature and help the atoms to connect together. Electrons are just as important and are responsible for electricity also. The different sizes of sticks are not necessarily important for primary age and are an optional extra level of learning. So, to keep it simple, any stick at all will do simply as an electron. So, keep it simple and just have fun. So, to do a quick recap, everything we've discussed and that you will be doing will fall under just 4 very simple basic rules. All of the balls represent atoms, but each color represents a different element. The sticks are electrons. When one or more atom holds hands, they form a molecule, and atoms never disappear. Nature always reuses its atoms. And if you can get them four basic rules down, you'll be doing really well. These little atoms and molecules act as a chassis to complement your existing lesson plans for a more intuitive reconsolidation of memory information process based on hands-on practical use and knowledge rather than memory alone. Our framework essentially is plagiarizing nature itself. This is not only a hypothetical concept, but it's how nature actually really builds all stuff. Atoms are nature's Lego. As explained, atoms are so friendly. All they want to do is make friends with other atoms. They're very social, and when they do, they build famous molecules that we all know and love, like H2O. H2O also wants to play and make shapes and interact in lots of different and interesting ways. The results of these playful interaction builds a liquid that we call water. You'll note the H in H2O stands for hydrogen and the O stands for oxygen. Because there is only one O and two H's, so intuitively we call this H2O. And we find kids from second class up figure this out by themselves. And they make the prediction when we're talking about CO2. CO2, of course, has one carbon and two oxygens. So that's why we call it CO2, also known as carbon dioxide, and is vital to know about climate change. Knowing this little thing is the difference between learning about climate change and understanding climate change. Another example is O2, which is two oxygens. Sometimes molecules can have a love-hate relationship and break up in a fiery or gaseous or foamy bloated divorce. We call this a reaction, and it's how your food digests, or how your house is heated, or how fossil fuels burn, or how we cook food. Okay, now that we've gotten down with how easy it is to use atoms and molecules, let's take a more detailed look at how these resources can help add connectivity to all of your existing science lessons. As explored, atoms use their spare electrons to hold hands and make molecules. And how those molecules interact with each other will determine their state of matter, whether it's a solid, a liquid, or a gas. In this display, in the solid section, the atoms and molecules are all connecting tightly to form a big structure that gets bigger and bigger. In the liquid section, however, the atoms make individual small molecules that don't connect like above, but are extremely close to each other. They can't directly connect because they ran out of spare electrons, but under the right conditions, they can form water like we have here on Earth. But for other small molecules, if the pressure or conditions is right, the molecules get dispersed, creating big gaps in between the molecules, and they become a gas. Molecules can demonstrate heat and cold. When mass or stuff feels hot, it means that the molecules are jiggling faster. When stuff cools down, it means the molecules in the object are jiggling more slowly. Electricity is when atoms play a relay race with their spare electrons. This generates a current in the conductive metal wire, which also affects the field outside the wire. Magnetism can be explained using atoms too. Atoms themselves are each like a mini magnet with their own magnetic field. And when their fields all align and point in the same direction, the object becomes magnetic. Gravity can be explained using atoms. The very presence of one or more atom will warp spacetime, creating a gravitational force. The more atoms that join together, the heavier the mass, the bigger the gravitational pull. Enough atoms and you'll have a Jupiter, a giant planet made of gas. Or bigger again, our own sun. In fact, our sun right now is building elemental groups of atoms ranging from hydrogen to iron, and lots of other stars just like it can build even heavier elements, and even heavier ones again if they exploded in a supernova. All atoms come from dead stars, so we are all made of star stuff, to quote Carl Sagan. All planets in our solar system orbit the sun because it warps spacetime so much, so they can't escape. Living things are defined by their cells, and these cells are all made up of stuff that are large, complex molecules. And at the center of our cells is a very special molecule called DNA. Our DNA stores all the information about ourselves, determining our eye color, our hair, our height, and all our biological makeup. This is a self-replicating molecule that can pass on genetic information, allowing life to adapt to its environment via the process of evolution. Living things also expand into healthy eating and can invoke a healthy interest in future careers in food science or biology. Non-living things such as geology or materials is the area where shapes of molecules also matter. You can get different materials from the same family of atoms. These variants of materials are known as allotropes. Sound is another area that's easily explained and understood using these ball and stick molecule sets. When molecules form pressure waves, it allows sound to travel. If you sucked all of the air molecules out of a room, no sound could happen. This little display is also great to show the composition of the air that is all around us, such as nitrogen, N2, or oxygen, O2, and various other gases such as methane, if somebody farted. These ideas are not only amazing to help the student discover how nature works, but they also offer a massive advantage for the teacher by building these resources themselves. By looking and creating, you learn. It's a look, read, and understand method where the resources will guide you without you needing to be proficient at science or taking out the textbooks every so often. Simply look at the shapes, connections, and gaps, or read the labels, and you won't go too far wrong. We will cover all these over later episodes, so don't forget to like and subscribe and keep up to date. So we covered mass or stuff, and the rest of nature is light, energy, or forces. We will be covering all of these in later episodes, but just check out this really cool resource on light. If you purchase a red, green, and blue LED torch online, you can demonstrate to the students how white light is made of various other wavelengths. Our eyes don't see, but rather detect wavelengths, and our brains perceive these wavelengths as colors. And by overlapping all three colors all together, you can make white light. There are also lots of other types of light that nature has to offer that our eyes can't see or detect, but we have machines that can. And again, in later episodes, we'll briefly look through these as they're really interesting. So we've covered the basic blocks of nature and reality, and it's as easy as Lego. If everything is explained by something that the atom or the electron or the molecule does, then you have a great place to start. So let's take a look at the learning outcomes of the Science Lesson Support System. It will enable all students to learn what atoms and light and forces are, and that they have a relationship to each other. This builds confidence and removes intimidation of science from an early age. And it also helps to arm against misinformation and disinformation via this knowledge. Most will be enabled to attain a good chassis to attach the teacher's existing lessons for the future intuitive reconsolidation of memory. Meaning, instead of having to memorize facts, you can build up from what you know about nature's rule book. And finally, some will discover within themselves a really deep passion for science and to carry out self-dedicated research. More importantly, they will begin to learn what questions to ask. And though this doesn't sound important, it really, really is in science. And it's very impactful for future scientists and STEM careers. So let's look at the outcomes for the educator. You're not expected to teach chemistry per se. You're simply exposing the student to a basic set of rules. Rules which the laws of nature is built on. This becomes our alphabet equivalent to language, your rock, a stable, consistent guide. It will navigate and add depth to your existing lesson plan. Don't overthink it. Keep it simple, have fun, and just expose the students to the building blocks of all things, and all things will connect. The displays you build and labels will act as a guide and speak for themselves, reminding you at one glance what's going on. It's literally read and understand. As soon as students understand that nature has a basic set of rules that are applied to all facts, areas, and topics, then remembering is replaced with understanding. Our easy to follow videos will provide step by step lessons and resource creation ideas. And you will learn while building these, and you'll have fun too. Enjoy the process. Connecting these atoms together is actually quite relaxing. So get Googling and ordering and have fun building with me over the course of my next few videos. These resources are tough, durable, and don't discolor. Though we all learn differently, what we do have in common is the indisputable power of holding something physical in your hand and having that thing relate to everything else, creating a mind map. Next time, we'll be showing you just how to arrange all of your atoms into easy to manage packs, along with step-by-step lesson plans on climate change and the combustion cycle. So don't miss it. And that's it for this episode and our introduction to the Science Lesson Support System to help make science make sense. I've been your host, Paul Burton. And remember, you're not just teaching STEM, you're telling a story, the true story of nature.